Hello and welcome to video number 10 of Rick's Pipe Dream Magnetic Motor Generator Project Series. I'll be picking right up where I left off on video 9, and we're looking at the same view. This is showing the stator arm and the stator mounting block. And I have you can see that the T-fitting up here is positioned actually at a 0-degree angle from horizontal, so that it's perfectly aligned with the wheel rim. And as I said before, it's sloping down at the same angle that the rim is manufactured at, which is an 8-degree angle. Now, my spacing in between the hard drive magnet and the rotor magnets is, I don't know if you can see it here, 1 inch. I find that to be a good level for operation. I can bring it closer, however, I get a little worried about the rotor magnets being yanked away from the wheel rim and smashing into the hard drive magnet, in which case they will break. There's no doubt about it. They shatter very easily if that occurs. Now, you'll see that my rotor magnets are 3/8 inch wide, and let me just hold a ruler up. You can see that they're 3/8 of an inch wide, and they're 1/8 of an inch thick, but I have them stacked 2 together, so that gives me a 1/4 inch of thickness there. And there's a 5/8 inch space, 5/8 in between each of the rotor magnets. So 5/8 and 3/8, that's 1 inch, right? And you can see there, it's a 1 inch space. Okay, so we have 1 inch in between and 1 inch this way. Now, I can't really get around to show you the back angle from the side without moving the camera right now, but if I were to show you that, you'd see that the overall width of the stator magnet is actually 1 inch also. So I have an interesting relationship there. Now, of course, due to the spacing here of these magnets, center to center is going to be 1 inch, right? And you can see I've put a piece of paper into the back here, and this is placed here with markings on it, so you can see the south side of the stator magnet is placed there, and the north is over here on this side of the magnet. See? Now here's a loose hard drive magnet, which is the mated pair to the hard drive magnet that's up on the stator block. In the hard drive, they're used in combination as a pair, and that's how they're used to operate. Now the magnetization is very, very strong on this side of the hard drive magnet. Now you can see that the magnet is mounted on a steel plate. The magnet is 1/4 inch thick, and you can see that if I bring the ruler back up here, 1/4 inch thickness. And the mounting plate, the steel mounting plate, is also 1/4 inch thick. Now there's very strong magnetization, as I say, on this face of the hard drive magnet. If I flip that over and place a paper clip up here, you'll see that there's really no attraction whatever. None at all. There just isn't any attraction there. Now, let me show you something here. In the center of this group of magnets, which is where I'm residing right now, there's an equilibrium effect between the stator magnet and the rotor magnets. It's very easy to turn the wheel in either direction at this point. You see, back and forth, it moves effortlessly. However, at either end of the group, there's a strong action. If I let go of the wheel, it wants to rotate towards the right. And if I bring the other magnet and the end of the magnet group into play here, at this end, there's also a strong attraction and also a repulsion effect as it goes by the stator. So the strong points are at either end of the group. Now this end, well, actually, as I showed you, both ends, the wheel wants to rotate to the right. You see that? Both ends want to rotate to the right. Now the starting point, since we want to rotate to the right, we should start at the right end. And the strongest point of rotation would be right here, because we have a south-facing magnet. In other words, south is facing up towards the stator magnet, and you would think that we would have equilibrium here, because there's a south facing a north, which is attraction, and here we have south facing south, which is repulsion. However, the repulsion effect is very strong at this point, since the wheel rim takes on a north pole at this point. So the north is pushing the wheel away, because the wheel is north, and that draws the south into the attraction here, and at the same time the south of the stator is pushing this south-facing magnet away in repulsion. So we have two repulsion effects and one attraction effect at that point. Now if I line this up properly, right about here, so that the first magnet is right in this area, underneath the south end of the stator magnet, it's going to want to rotate, and it's going to rotate to the right very strongly, because the repulsion effect is strong. Now watch. Okay. Now I'll be explaining what happened at the second group. It looks like I'm just about out of time.